So I'm presenting this on behalf of my co-authors, Catherine Fear and Edna Roberts and Gennaro Esposito. This paper is in fact a summary of a study that started in 2012 in the COSIA fines capture working group, and at that time the project was awarded to AMEC. Angela Cooper was the technical lead for this project. The idea was to review a number of case studies to have an evaluation of the fines capture in the beaches for commercial cases and also lab and field trials, and to review the operational approach that can enhance fines capture in the beaches. I should mention that this study didn't review the CT or NSC deposit. It was just the whole tailings. And here I've provided a link to the report that is available on the COSIA website. And please note that this link is the right one. The link that is in the paper in the proceedings was updated later, so you can search it in the COSIA website. And a few definitions. So fines capture can be defined as the mass of fines that are captured in a beach deposit compared to the total fines that are introduced into a tailings disposal area. The mass of fines in the tailings slurry is equal to the mass of fines in the ore minus the fines in the rejects. And the fines captured can be calculated by two approaches. One is the direct method, in which you calculate the volume of the beach, measure its density and fines content, and multiply these to calculate the mass of fines in the beach, and divide that by the total mass of fines introduced into the tailings pond. The other method is the subtraction method, or indirect method, in which you measure the mass of fines in the fluid tailings and subtract that from the total fines and divide it by the total. So in this study, a number of commercial tailings facilities were reviewed. These were CNRL's Horizon ETF, Shell's MRM ETF, and Syncrude's Aurora settling basin. For the Shell case, the northeast beach of the MRM pond was also reviewed by itself. In addition to these, there were some limited information available for other commercial case reports. These were Suncor's Pond 1, Syncrude's Mildred Lake settling basin, and Southwest Sand Storage and beach above water deposits. In addition to the commercial case records, we also reviewed the field trials that were available in the public domain and some flume tests that were done by Total and shared with COSIA. The field trials, a number of them were uncontained trials. These were the beach above trials that are covered in Angela Cooper's thesis and were run at Syncrude. The contained beaching trials included the Oslo one, and also as listed here, the Syncrude's Mildred Lake settling basin one. So for the three commercial case reports, the data were the operational history of the three cases were reviewed, and the data indicated that there is frequent variations in the slurry properties, and it was noticed that the flow rate, density, and fines content of the slurry changes significantly at times, and about 10 to 20% of the time the slurry had a density lower than 1100. And as we mentioned in one paper 2 years ago, these periods of lower density can cause flushing of the fines in the beach above water, and also can cause instability of the beach below water and collapse of the beach below water and in capturing of the fines. So for the commercial case records, the beach was divided into different zones based on their depositional environment. The beach above water, beach below water, and pond center. It was observed that the fines content in the beach below water was higher than beach above water, and also in the beach below water, as we move from the shoreline towards the pond center, the fines content was increasing. And also it was found that the beach below water had a higher fines capture compared to beach above water. And the physical mechanisms were a metastable structure that the beach below water forms, and the collapse of this structure and turbidity currents in capturing of the fines. So this table shows a summary of the findings of this study. As you can see, for the commercial case records, the fines captures are from about 60 to close to 80%. And for the uncontained beach above water trials, the fines captures were around 20 to 40%. And there were a number of cases that we had that were not commercial case reports, but we had high fines capture. I will go through these in a bit more detail. I should mention that for the total flume test, there we have the fines capture that is mentioned there is for a fines content that was close to the operational cases. So total tests had some scenarios that we had much higher fines captures, but the fines content of those cases were not comparable to the operational cases. So based on the table that I just showed, for the commercial case reports, a number of factors were identified that contribute to higher fines captures. We noticed that the more mature the pond and the deeper the pond, the higher was the fines capture. Also, the geometry of the pond did matter. The more circular the facility, the more interfingering of the beaches would happen in the center of the pond, and it will result in higher fines capture. Internal prostites also, for the cases that we had lower flow rates and higher densities, we had higher fines capture. We didn't focus that much on the chemistry of the water in this study, but as I will explain, for the northeast beach of Shell, we believe that chemistry also played a role. So as I mentioned, for the beach above water cases, the fines capture was around 20 to 40%, and for the Mildred Lake settling basin one, which was a contained beaching, and also for the northeast beach of Shell MRM, the fines captures were around 65-66%. The Shell MRM Northeast Beach is an interesting case. We presented a paper 2 years ago in this conference explaining what happened there. As a brief overview, this image shows the original prospect that was built there, and this area was supposed to receive only TT and TSRU, but after a couple of years, CST was also poured into this area, and gradually a long beach formed here. So this cross section briefly shows, in fact, schematically shows what happened in this area. As you can see, the zone between the larger dike and the cross dike is a large contained area which helped higher fines capture. Gradually after forming, after the beach formed, the length of the beach is about 1,400 meters. So you can imagine that when the slurry is discharged on top of this long beach, the velocity reduces and fines have a chance to settle more. And also this helped more fines capture in the main pond as well. So this diagram shows the case records that we reviewed in this study. The general trend that was observed was that as you increase the sand to fine ratio of this slurry, the fines content of the beach reduces. For the contained beaches, the fines content was higher than the uncontained beaches. And for the commercial case records, you can see that the fines content, and this is the global fines content. It includes the fines in the beach above water, beach below water, and pond center. It's significantly higher than the field trials. And for the specific case of Shell MRM North Beach, you can see that the fines content is about 25%. That's marked as co-disposal, where the TT, TSRU, and CST were discharged into that north corner. Also, it was noticed that as the fines content of the slurry reduces, the fines capture increases, basically because initially less fines were introduced into the tailings slurry. There is a section in the report that talks about predicting fines capture, and generally it states that there are no existing models that can predict the fines capture for a commercial tailings facility. There has been a common model by Mr. Marsh at Syncrude that was defined by Mr. Marsh, and it's been used. Basically, it assumes that we have 100% sand capture and the sand skeleton is formed, and a percentage of fines are captured within the void spaces of that sand skeleton. But this model cannot be useful for the beach below water deposits. So here there may be an opportunity for further research on making models or creating models for predicting fines capture in these beaches. So in summary, this study showed that for commercial case records, the global fines capture can be as high as 70 to 80%. And the beach below water played an important role in this fines capture. The uncontained beach above water deposits usually have a lower fines capture, between 20 to 40%. It was shown that the containment or backpressure effects are very important in creating a deposit with higher fines capture, as what was observed in the Mildred Lake settling basin and the MRM ETF northeast corner. And generally, for the segregating slurries with higher fines content, the resulting beach will also have a higher fines content, but the fines capture will drop on a percentage basis. And also, one of the recommendations of this study was to consider co-disposal of fine and coarse streams, like what happened in Shell's Northeast Beach, that could possibly increase the fines capture in the beaches. I would like to acknowledge the work of my team members in the COSIA fines capture working group. Angela Cooper played an instrumental role in this study. We appreciate her support in this project. At the time of doing this study, Alex Zangolzo was the head of the fines capture working group, and Alan Fer did support this study a lot. and the rest of colleagues who are listed there did play an important role. Thank you.